Hello everyone. So here's another differential equation in higher order form, order 4. No? And let's solve and find out if this differential equation falls, whether case 1 or case 2 or a mix. Okay, so we have uh, dy order 4 dy dt. No, our variables are y and t. So we have fourth derivative of y with respect to t minus 2, third derivative of y with respect to t minus 13, second derivative of y with respect to t, and plus 38 dy dt minus 24y is equal to 0. So let's transform this using the differential operator d, but take note that our another variable is in terms of t. Okay, so let's not forget it. Let's not forget it because we will be using these variables later on. Because when we use the differential operator d, we cannot see the variables, specifically the independent variable later. Okay, so we have d4 minus 2 d cube minus 13 d derivative, second derivative, plus 38 first derivative minus 24. So since uh, we have only here y, and so we don't have the operator d because that is only stands for the derivative. Okay, and y is equal to 0. So now after having this, then we can now easily get our auxiliary equation or the characteristic equation. Okay, let me use the other term for auxiliary equation, which is the characteristic equation. So we have m4 minus 2 m cubed minus 13 m squared plus 38 m minus 24 is equal to 0. Okay, so as you can see, we have a slightly complex given of differential equation. So we have up to the raised to 4 order or in the fourth order. So we cannot easily simply find the roots of this given uh, equation. So let's use the synthetic division, okay, to find the roots of these four roots of this given characteristic equation. Okay, so what we do is from this to this part, let's call it the constant coefficients as q and p. Okay, and then um, the the roots can be found using the synthetic division, and let's use numbers p over q, wherein these p over q, we need to identify the factors of p and the q. And for that, we have the factors of this p, our negative 24. So we have plus negative 1, also plus negative 2, plus negative 3, what else? Plus negative 4, and also plus negative 8, plus negative 12, and then plus negative 24, right? Okay, and then for q, since this is 1, so we have plus minus 1. So by using this, okay, we will try to find the roots by choosing one by one, which will be qualify as our root when we use the synthetic division. Okay, so let's try so this is actually tedious because we will do a trial and error. So let's try positive 1 over positive 1. So p, let's choose first 1. So try p over q is equal to 1 over 1 or just 1. So using the synthetic division, so we need to get each coefficients one by one of our initial characteristic equation. So we have, at this point, so we have 1, we have negative 2, we have negative 13, we have positive 38, and negative 24. So by the way, we need to complete these terms from fourth, third, second, first power, and then the 0, m raised to 0. Okay. But since we have the complete set, then we can easily write each coefficients from 4, 3, 2, 1, and then 0, m raised to 0. So we have these terms 1, negative 2, 13, negative 13, plus 38, plus 24. Okay. So by the way, in case, say, we have a set like, for example, this part is 0, then instead of negative 13, to complete the from 4 to the m raised to 0, you need to write down here 0, okay, to complete the set from 4, 3, 2, uh, 1, and 0. Okay. But since this is given, then no need to complete the set by filling up 0 because we know already the values of the coefficients from 4 to 1 up to the raised to 0, m raised to 0. Okay. So, by the way, let's now go back to our synthetic division. Okay. So, we will use 1. So, let's do the synthetic division by using 1. Okay. So, first term, need to bring down this number. So, 1. Then 1 multiplied by 1, we have 1. And then add the remaining terms. So we have negative 2 plus 1, we have negative 1. Then again, negative 1 times 1, so we have negative 1. Then add this term, so we have negative 14. Then negative 14 times 1, we have negative 14. And then uh, 38 plus negative 14, so we have 24, positive 24. And then positive 24 multiplied by 1, we have positive 24. Then when you add this one, we come up with 0. If we uh, we come up here with 0, then our chosen um, number is said to be the root of the characteristic equation. So therefore, m is equal to 1. So we already find one root, which is 1. Okay. So to continue the synthetic division, okay, so since we already know that m is equal to 1, we can reduce this equation. Since this is raised to 4, then we can use this term now as m. So 1m raised to 3 minus 1m squared minus 14m plus 24 is equal to 0. Okay, and from this equation, once again, we get the coefficient. So we have 1, negative 1, minus 14, plus 24. Okay, and then divide it by, use the synthetic division. Okay, but first, find again the P over Q. So if this is our Q, and it so happen that the last part or the P is also equal to 24. So we can use the same set of P and Q. But since we have already tried 1, so now maybe let's try positive 2. Let's try positive 2 over positive 1 or 2. So let's try 2 if we can come up with 0 at the end. Okay, so bring down 1, then 1 times 2, we have positive 2, and then negative 2 plus 2, we have positive 1. Then positive 1 times 2, so we have 2. And then, so we have negative 12. So negative 12 times 2, we have negative 24. And adding these 2, we have 0. So therefore, we say that another root is 2. Okay. This time, we can now reduce from this equation to the second power. So we have m squared plus m minus 12 is equal to 0. And as you can see, we can also continue by using the synthetic division P and Q by trying all the factors of P and Q, divide the factors of P and Q with each other and try if you can come up with 0. But in this term, m squared plus n minus 12, um, we can easily use the factorial, which is need to think of a number like we did before, that when we multiply it, each number, we will come up with negative 12, but if we add those numbers, we will come up with positive 1. So 12 is, we have 4 and 3, so 4 and negative 3. So 4 positive 4 times negative 3 is, we have negative 12, and positive 4 plus 3, we have positive 1. Okay, so therefore, but also of course you can check by multiplying these factors. Okay, so therefore, going back, another roots are 4, m plus 4 is equal to 0, or m is equal to negative 4. And then for the another one, m minus 3 is equal to 0, or m is equal to 3. So therefore, our roots are, we have 1, 2, negative 4, and 3. So we have m1 is equal to 1, m2 is equal to 2, m3 is equal to negative 4, and m4 is equal to 3. Okay. You can rearrange these roots from lowest to highest, but um, that is for the formality. But we can also use this as is. There's no problem if your m1 is 1, 2, and then your m3 is negative 4, and then m4 is negative 3, or vice versa. Okay. So our general solution, since we have distinct real roots, four distinct real roots, then we have a, say, c1 e raised to 1x plus c2 raised to 2x plus c3 negative 4x plus c4 raised to 3x. Oh, by the way, before I forgot, I said that we need to, since our given variables are in terms of y and t, then let's use t instead of x. Okay, let me correct this part. So we have c1 e to the t plus c2 e to t plus c3 negative 4t plus c4 3t. Okay, so that's it. Okay. Okay, you can write like this, or if you want uh, to rearrange these things, then usually we set m1 as the lowest root. So you can also use m1 as negative 4, m2 as 1, m3 as 2, and then m4 is equal to 3. Okay, so therefore, if you use these roots, then we have c1 e negative 4t plus c2 e t plus c3 e 2t, and lastly we have c4 e 3t. Okay, so that's all for this video, and once again, we can use the synthetic division to find the roots if we have this kind of higher order differential equation. Okay, and if we already reduce it in, second order, then we can easily use the factorial, or by factoring this, because this might be an easier method, uh, unlike the factorial one. But you can also try the uh, synthetic division as well. Okay, so that's all, and see you on the next video.